Alright, this is going to be a video on the motion graph conversion CASTLE learning assignment. On the worksheet I gave out, the physical copy has 4 questions. There's an extra question on the CASTLE learning assignment. So I'm just going to do the first 4 questions on the worksheet first, and then I'll do the extra question on the CASTLE learning. So on the worksheet only, which pair of graphs represents the same motion? Now, first thing you want to do is you want to be able to interpret the lines. Okay. So on this PT graph, if you see a constant line, you see a slope of 0, well, that must mean it's not moving anywhere, right? That must mean on its y-axis, if I see a straight line here, I'm staying at the same position. And if I were to write a number, let's say 5 meters, well, I'm still at 5 meters over this period of time. So that means I'm not moving at all. And we know that since slope is velocity on a PT graph, then we also know that if it's not moving, we know our velocity, our speed is 0. And if our speed is 0, then our VT graph the line must be over here, and it might not be too clear. Basically, on choice A, what this is saying is that it's not 0. It's at a constant velocity that's not 0. Let's say this is 5. So it's at a constant velocity that's not 0. And so there's no way choice A is correct. Let's move to choice B. Choice B gives you a curving line. Okay? We talked about this. If it looks like it's coming to a straight horizontal line, well, again, we talked about this up here. If you have a straight horizontal line, you're not moving anymore. You're at rest. And so if it looks like it's curving to a straight horizontal line, we know that it's coming to a rest. We know that it's slowing down. Okay? I want you to think of it like that. And if it's slowing down, that must mean we have a changing velocity. Well, we know it's a changing velocity because it's a changing slope, right? That doesn't need clarification. If the slope is changing, then we have a changing velocity. This goes hand in hand. Goes hand in hand. And if we have a changing velocity, well, this right here, this line says that my velocity is always at, let's give it a number, like 5 meters per second. I'm sorry. This line is basically saying that my velocity is always 5 meters per second over time. But that can't be true. We have a changing velocity. There's no way this can be true. We have a changing velocity, we have a changing slope. So there's no way this is possible. A better representation would be this. You have a changing velocity, and you have an acceleration. Alright, deal with that later. And C, oh wait, choice C. Choice C, you'll realize, well, let's just analyze the graph first. So you have a P, T, and then we have a curve like this. Now this curve is a bit different. This curve is a bit different. Instead of going into a straight horizontal line, we're increasing our slope. Our slope is increasing, right? We started from a horizontal line, and then we're slowly speeding up. So this right here this is a graph of something speeding up. Okay. Well, if we're speeding up, that also must mean we have a changing slope, and you don't really need to even call it again. Like choice B, you didn't need to call it whether was it speeding up or slowing down. You know it's a changing slope, right? It's not a constant slope anymore. This would be a constant slope. This is a constant slope, right? This is a constant slope. But we know our slope is changing. That must also mean we have a changing velocity. And now the VT graph right here, we see this line right here. We have a slope. Now also must mean, well, if we just call this 1 and call this 5, at this point in time where our velocity is 1 meters per second, at this point in time our velocity is 5 meters per second. Well, is our velocity changing? Yes, it is. So slope is constant. This the slope on a VT graph is acceleration. So that's not a good example to use. So the only thing you're focusing on is, well, I realize that this slope has a changing slope. That must mean it's changing velocity. Well, this graph has a changing velocity as well. This graph has a changing velocity. I'm going from 1 to 5. So C is the correct answer. Let's actually go over what D means first. Choice D. And so this is a graph straight line down. Well, if you're going down, you have a negative slope. Okay, you have a negative slope. And you have a constant slope. So you have a constant negative velocity. And so your VT graph right here, and I'm going to draw what it says here, it's saying that your velocity is positive. You know, I've been stressing to you, well, negative direction, we do like this, and this is 0, and this is a positive, and this is negative, and this is B, and this is C. If you have a constant negative velocity, you're going to see a straight line below the x-axis. That's what you're going to see. You're not going to see anything else. Let's move on to this. So the correct answer is C, choice C. Choice number 2. Yeah, it's the same type of interpretation. Well, what are these graphs saying? It's a constant slope. It's moving forward, so we can say it's a what's it? Oh yeah, constant positive velocity. And we have V T, that is constant velocity. Right? It's staying at the same velocity. Let's give this a number. 5 meters per second. So you can see over time, we're still at 5 meters per second. Our velocity is still 5 meters per second. All right, so that's the answer. I already covered the other interpretations in the first answer, so I'm not going to cover that. So choice 3, which paragraphs represents the, question 3, which paragraphs represents the vertical motion of an object falling freely from rest? If you know something is falling freely from rest, then you know that you have a negative acceleration. All right? You know you have a negative acceleration. Now, it doesn't look, I'm looking at these graphs right now, and then these are regions, questions, graphs. None of them, the velocity, I don't see a negative velocity anywhere, negative acceleration rather. So I'm gonna assume for this question, they're gonna assume that everything is positive. So in this question, they're gonna assume that, well, they don't assume that everything is positive. They assume that the downward direction is positive. All right, so if they're assuming the downward direction is positive, then that must mean that my acceleration is 9.8 meters per second squared down. All right, so they're assuming that your downward direction is positive. Let's get rid of that. So now that we've established that we do have an acceleration, our VT graph should look something like this. If we have an acceleration, if acceleration is not 0, that must mean our velocity changes, because that is the definition of acceleration. Your acceleration is change in velocity over time. So if we do have an acceleration, we know our v changes. And so if our velocity is changing, we're going to have a changing, well, I just repeated the definition. You're going to have a changing velocity. The other two graphs, we never really covered curves on a VT graph. And because we never covered curves on a VT graph, you can assume that those probably aren't the correct choices. So you're picking either A or B. Now, if our velocity is changing, we know that on a PT graph, our slope is velocity. And if we have a constant slope, that must mean we have a constant velocity. But we don't want a constant slope. We don't want a constant slope at all. We want a changing velocity. And so we want a changing slope. We want a changing slope. We want a changing slope because our velocity changes. And so a changing slope would probably be this. It would be a curved line. Our slope is changing. And so the choice is B. Now let me go over the last question. This is question 5 on Castle Learning. It's question 4 on the worksheet. Which pair of graphs represents the same type of motion? I'm not going to explain this. Well, I am going to explain it. Now, let's look at choice A. We discussed this. If you have a curved line on a PT graph, you know your slope is changing. And if you know that your slope is velocity, that must mean that you have a changing velocity. And that must mean you have an acceleration. Your acceleration is not 0. Right? The step led into this step, that step led into this step, that step led into this. So you know you have a change in velocity, you know you have an acceleration. So on a VT graph, if you know your velocity is changing, that must mean that you have somewhat of a straight line. So our correct answer is A. Well, it was pretty simple. Let me cover the other questions, the other choices actually. I do want to cover the other choices. So choice B, you're starting from a negative position. So you're starting from a negative position and you're going upwards, and that must mean well, this is a positive slope. It's a positive slope. That must mean you have a positive velocity. It doesn't matter if it's negative here. You're still traveling in the positive direction. Getting closer and closer to the positive direction. And so if you have a positive velocity, your VT graph, this is a PT, your VT graph, if it's a positive velocity, it should be above the x-axis. But choice B has a velocity in the negative direction. I mean negative. So that must mean that the velocity there is saying it's a negative velocity. So that's obviously wrong. Let's look at this one. You have a negative slope here. You have a negative slope. And you have a constant slope. Again, it's not curving, it's constant, it's not changing. So that must mean you have a negative constant slope. Okay? A negative constant slope. And so what that would look like on a VT graph, let's call it 0, and it's negative, positive. The constant velocity line would be that. That would be a constant velocity line. Now D, let's look at 0 minus positive T P. All right. So what this is a graph is trying to say, well, you get to a certain position and then you travel back to 0, and you see this curved line. You see this curved line right here. That must mean if your slope is changing slope, so changing velocity. So you have a positive velocity here and a negative velocity here. Well, the only thing that matters is that your velocity is changing. So if your velocity is changing on a VT graph, there's no way you're gonna have a straight line here. There's no way. Instead, if you had a changing velocity, and I think it's a positive or negative velocity, you're gonna have changing. You're actually gonna have, well, what it looks like doesn't matter. I'm not gonna explain it too deeply because you don't really need to know. That would be what it would look like. But the only thing you actually had to know for this problem is that if you had a changing slope, you had a changing velocity. But what this graph is saying is that your velocity is constant. There's no way that this is correct. Let's do the question that's on Castle Learning, the extra question. So this is question 4 on Castle Learning. Which combination of graphs best describes free fall motion? We know that in free fall, there's a negative acceleration of negative 9.8 meters per second squared. All right. So the first choice A, represents, again, you have a constant slope. So constant velocity, and we know it's positive as well because it's positive slope, so we can say it's constant positive velocity. Let me not delete that for a second. Choice B, this is PT again. This is a changing slope. So this is a changing slope, and its slope is still positive, so we can say, well, it's a changing positive velocity. Okay. So let's look at choice C. Choice C gives you a straight line. And that line is at a certain velocity. So that, well, that's a constant velocity because it's staying at the same number. So this would match this graph. This VT graph would match this one. Let's look at choice D. Choice D has a changing velocity and has an acceleration. So let's look at this, and we have a straight line, and this is our slope. So our velocity is indeed changing. And this matches this graph. Changing slope. That must mean on a PT graph, we have a changing velocity. And here we have changing velocity. This is VT graph. And so this would be 0, 1, 2. Yes, our velocity is indeed changing. So it is, we have to answer it first. A and C, choice 1 would be correct. A and C match. B and D, which best describes free fall motion? Oh, best describes free fall motion. I'm sorry. So what best describes free fall motion is that if you have an acceleration, that must mean that you have a changing velocity. Again, changing velocity means that your acceleration cannot be 0. Acceleration cannot be 0. So changing velocity, acceleration can't be 0, so it has to be number 2, B and D. So that's the answer. That's the end of this video.